I'm going to go ahead and leave you to this. It's pretty basic and straightforward. Each of these are really one of each of the type of things that we've been looking at. For this one here, we want to find the probability of 3 white t-shirts in a row, which means white t-shirt and white t-shirt and white t-shirt. And I don't know about your teachers, but I've been emphasizing that and when we're talking about probability means or. Even if it doesn't actually say the word and in it, if the idea is and, it means multiplication. Or means addition, and means multiplication. So we want to know what is the probability that it's 3 whites in a row. Well, there's 5 out of a total of 15. Is that right? 15, yeah. Now, we didn't say we're going to put them back. That's weird. So the next probability changes. It's only 4 white ones left, but there's also only 14 shirts in the drawer. And then again, and multiplication, there's only 3 white ones left, but then there's only 12 left in the drawer. So I'm going to go ahead and reduce a bunch. Do you see that 4 times 3 is 12? So I'm just going to reduce all that mess. And then 5 goes into both of those. So the numerator all becomes a 1, and your denominator is just really 3 times 14. Did I do that right? Oh, just kidding. I can't count. That's a 13. Oh, lovely. Just kidding. Okay, so let's see. 4 and 14, 2 goes into both of those. So that would be 2 and 7. And then nothing goes into 3 and 13, but 3 and 3 goes in there. So what we have left is a 2 out of 13 times 7, which is our 91. So my bad. I guess I need to learn how to count. That's good. Let's look at this next one here. So here is craziness. So we have 14 white with holes. And this is our strategy of making a list because there's really just so much stuff going on. So we have then 22 black with holes. And we have 6 white without holes. And the rest are black without holes. So we need to say, well, there's a total of 52 socks. So then that must mean that we have a 10 black without holes. So if he reaches into the to grab a black sock, what's the probability that it does not have holes? So we're going to say that he grabbed a black sock, and that is a total of 32. And the probability that it does not have holes, there's only 10 of those. So we do want to reduce. 2 goes into both of those. That would give us 5/16 as our answer. And then our last one is this one here. Decide whether to appoint Dennis or Tommy. And then, so we've got this probability of choosing someone. And then if someone starts, we have a chance of winning, and if someone else starts, we have a different chance of winning. This is our little tree diagram. So we have Dennis or Tommy, but he's 90% sure that Dennis is going to start, so that only leaves 10% for Tommy. And then if Dennis starts, we have an 80% chance of winning, which means only 20% of not. And if Tommy starts, we have a 70% chance of winning, and then only 30% chance if not. And we want to know the probability that he wins the game. So these are the situations, but I'm not going to add those two together. That's 158%. Remember, I need to multiply these. Remember, the chart is just getting us set up and ready to go. Then we need to actually multiply these together. So this would be 72%, and this here would be 7%. So when I add those two together, I do get my 79%.